Alright, what's up guys? In this video, I'm going to pick up with some multivariable calculus. Going to be talking about the unit binormal vector and the torsion, or specifically how to find them. So in this case, we're asked to compute the unit binormal vector and the torsion of the following curve R of t, which is given here. Okay, so doing this isn't hard. It's a relatively easy procedure, but it is quite lengthy to find the answer to this. So if you're going to practice this on your own, you'll need a couple sheets of paper. So what do we need? So let's just talk about the formula in this particular case that we need to essentially deal with for our unit binormal vector and torsion. Okay, so remember for the unit binormal vector, that's just going to be B is equal to T cross N. Okay. Now remember, T here is the unit tangent vector. Hopefully you remember that. And N here is the principal unit normal vector. And we already know how to calculate, or we should know how to calculate, the unit tangent vector. If you don't, I'll remind you. I do have videos on unit tangent vector as well. So remember, the unit tangent vector, that's just T of t, is equal to the first derivative of R of t, all divided by the magnitude of the first derivative of R of t. That's how we compute the unit tangent vector. And in some cases, it can be done at a point. It's not this case, but it can be. So again, nothing in here is hard to do, but it's lengthy. So we just gotta keep going with the process. So the first thing we do is just take the derivative and just start chipping away at our answers. Okay, so let's just take our derivatives. So it looks like we'll get 12. Well, that's gonna be minus 5 sine t. I just brought the negative to the front. And then this would be 5 cosine of t. You're essentially just taking the derivative of each component of R of t. So that would be our first derivative. Let's get the magnitude, also known as the norm. We'll get that part out of the way. So remember, that's the square root of the sum of the components squared. So that would be 12 squared plus negative 5 sine of t squared plus 5 cosine of t squared. Then we do some simplification. So this would be 144 plus 25. Don't forget we're squaring sine as well. So this would be sine squared of t plus 25 cosine squared of t. Now we know that sine squared of t plus cosine squared of t is equal to 1. And we also have common factor 25 between those two. So really this is just going to be the square root of 144 plus 25. And I think that's 169. And if you take the square root of that, we get 13. So we know that the magnitude, or the norm, the magnitude of R prime of t would just be equal to 13. So we're just chipping away at most of what we need to do. Again, nothing too hard, but just a bit lengthy. So let's keep going. All right, so since we got our first derivative now, we have the magnitude of our first derivative of R of t. We can go ahead and take care of the unit tangent vector because we know we need that. Okay, so let's go ahead and do that. So for our unit tangent vector, again, it's just t of t, and it's going to be R prime of t divided by the magnitude of R prime of t. So easy enough, that becomes 12 over 13. Negative 5 sine of t all over 13, comma 5 cosine of t all over 13. And that's what we'll need. All right, so we've taken care of our unit tangent vector. All right. So what about the principal normal vector, that n that we were talking about? So remember, to get n, that's just the derivative of the unit tangent vector with respect to t, and then after that, we essentially divide this by the magnitude of the first derivative of the unit tangent vector with respect to t. So let's first of all just get, and then we'll divide. In other words, what we're looking for is n is equal to dt over dt, and then it's going to be the magnitude, and again it's the derivative of the unit tangent vector with respect to t. All right, and we're going to talk about the torsion in just a bit. Okay, so let's go ahead and start chipping away at that. So in our particular case, we take the derivative with respect to t for our unit tangent vector. Well, 12 over 13, that's just, that's just a constant, so the derivative is 0. Then we'll have negative 5 cosine of t all over 13, and then we'll have negative 5 sine of t all over 13. We can get that magnitude out of the way, so we'll do that next. So in this case, you don't actually have to write down 0 squared. I'm just being technical with it, just not skipping any steps. So this would be negative 5 cosine of t all over 13. And then we'll keep it going. This would be negative 5 sine all over 13. Now, essentially, again, we're going to end up with essentially the same scenario, because we know that cosine squared of t plus sine squared of t is equal to 1. And essentially, because 0 squared is 0, we'd essentially just be left with the square root of 5 over 13 squared, which would just give us 5 over 13. So in actuality, the magnitude of the magnitude of the derivative of the unit tangent vector with respect to its independent variable, which is t, would just end up being 5 over 13. Okay. One important thing I need to mention about the principal normal vector n, and this is obviously very, very important to know the restriction here. Remember, we cannot have the derivative of our unit tangent vector with respect to its independent variable equaling 0. Okay. So, all right, so it looks like what we're going to get for n here will be 0, comma, negative 5 cosine of t all over 5 over 13, comma, negative 5 sine of t all over 5 over 13. Which we can simplify a little bit. It's probably best to do that. So obviously we'll just get 0. This would be negative cosine of t, and this would be negative sine of t. Just clean it up. Okay, so remember we wanted our unit binomial vector, that's b, is equal to the cross product of the unit tangent vector and the principal normal vector n. That's what we are essentially looking for. Alright, let's continue. And we'll talk about the torsion when we get there. But let's just finish going through the rest of the problem. So now we need the cross product. And all we do is use the results that we just got to get our cross product. And remember, for the cross product, we use the matrix method. You just draw your matrix, maybe a little bit smaller than the way I just drew it, but now we already know what's going to go in our second row, will be our unit tangent vector. And that was just 12 over 13. It was negative 5. It was negative 5 sine of t. Sorry, I had to go back and look. And then it was 5 cosine of t. And our principal normal vector n, that was just 0, negative cosine of t. And I'm going to put, typically you don't put commas in here, but I'm just trying to separate them because I didn't make the box big enough, or I didn't make the matrix big enough. So I'm just going to separate them with a comma here for just a moment because I didn't get a chance to expand it out a little better than that. So make it a little bigger, that way I ain't got to do that. Okay, so here's what we'll have. We'll have 12 or 13. Yeah, make the matrix a little bigger, that way I don't have to put commas in there. Because I don't want everything to be too close, that way you don't get confused. So I just made it a little bigger. Alright, there we go, that's a little better. Okay, so it's just cross product basically. So we know that we essentially take out or cancel out the first column and first row, leaving us with negative 5 sine of t, 5 cosine of t, negative cosine of t, and negative sine of t. Alright, now the second column and first row will go. So that's 12 over 13, 5 cosine of t. I'm just looking back at what we got. And then this would be 0 and minus sine of t. You tackle j. And then the last part, you don't have to actually write all this out. I'm just doing it for the purpose of the video. Because most times I can calculate cross product without having to write too much down. But for the purpose of the video, I'm just kind of writing everything down so that nobody gets lost. So now we cancel out the third column first row, leaves us with the following. And you tackle your k on the outside. So again, just a bit long. Alright, so we're almost there, but not quite. We keep going. So this stuff is actually going to simplify out quite easily, you'll see. So this would be 5 sine squared of t, and then this would be plus because it would essentially be 2 negatives in that case. So this would be plus 5 cosine squared of t. We'll change the signs and stuff like that in just a moment. You don't want to try to do too many things at once. That won't be good. Quick way to make a mistake, so take your time. And this part here is actually want to change to a minus, that I change to a plus. I know it will, but let's just finish writing everything down first. Okay, so what would our unit binormal vector be? Okay. Well, it looks like our unit binormal vector look like we're just going to get 5i plus 12 over 13 sine of t. J, that changed to a plus, remember. And then this would be minus 12 over 13 cosine of tk. So that takes care of the unit binomial vector. Then we'll start working on the torsion. And the reason why we had to calculate the unit binomial vector first is because to do the torsion, we need that. All right, so the last part is the torsion. And the reason why I didn't give you the definition or the formula for the torsion at the beginning is because I knew we had quite a bit of a problem to go through before we actually got there, so you likely would have forgotten it anyway. So just save it to the end. And we know we needed to obtain basically all of this information prior to even trying to find the torsion in the first place. So now we're on to our torsion now. And the only skills you really need for this, again, is just dot product, cross product, and whatnot. So remember the torsion is given by tau, which is the Greek letter. And tau is going to be equal to negative dB all over ds. And then it'll be the dot product of that with n, which is our principal normal vector. Okay? And this will be our torsion. Okay, so what do we get? So we'll have tau. Bring the negative on the outside. Be careful with that because that can easily create a problem. Okay, so it looks like we get 0, 12 over, well, I know 13 squared is 169, so this will be 169 cosine squared of t. It's actually, sorry, and we'll split it up. This will be minus, and then this will be sine squared of t. Now, what may be the better thing to do is to write it this way. Let me do it like this instead. So I was actually going to bring it down on the other side of the paper, but instead I'll do this: 12 over 169 cosine squared of t, comma, negative 12 over 169, because we got to take the dot product basically. So this is probably a little bit of a better way to do it. And then we just take our principal normal vector n. If we go back to our sheet, that was 0. That was 0, negative cosine of t, comma, negative sine of t. Okay, so we'll get tau. We still got a negative on the outside, so this will be 0 minus 12 over 169 squared of t, and this will be minus 12 over 169 and we do the simplification, so we get tau, which again represents our torsion. That's just a Greek letter, and it's going to be just 12 over 169, which we can't reduce, and this would be the torsion. So for the final answer for our torsion, or we were asked for the unit binomial vector, that was what we were asked for first. So, and then the torsion, the unit binomial vector, oh, right there, sorry, was 5i plus 12 over 13 sine of t j minus, yeah, I'll leave it on the outside, 12 over 13 cosine of t j. So that is our unit binomial vector, and this will be the torsion. And that's your answer. So as you can see, quite a bit of work went into that one, but that's your answer. All right, so I highly doubt you'll see anything like this on a test. It's just a little bit, like I said, it's not hard, but it's a little bit involved. So you won't likely see this on a test. But all right, so that is your answer. So let me know if you got any questions, and we'll see you next time.